Way too loud, isn't it? Sorry, I have a loud voice to begin with. I wouldn't use this at all, but they're recording the video here. Let me just get my little clicker thingy. That was one thing I forgot when I was setting up. Is this better? Can you hear me now? I work for Sprint now. Let's see if I can get the batteries in the right way. Yay. All right, I love having the after lunch spot. It's my absolute favorite, because especially after like big heavy pizzas in everybody's guts. So my name's Rich Mogull. We're going to move really fast through this session. And as a little bit of background on kind of what I'm going to talk about, it's going to be very DevOps and security DevOps focused. It's going to be what are some of the DevOps things that we can harness to make how we do security better on a bunch of different levels. I've got like 5 or 6 demos. I'm going to roll through stuff very quickly. This is an hour-plus presentation that I've condensed down to about 20 minutes to fit in my little slot here. Now, for those of you who do this stuff for a living, which isn't just a lot of you, but is some of you, you know, it may look pretty familiar, but I know, and I've got a little bit of background material to cover, but I know there's probably a bunch of you here that don't have a whole lot of experience with DevOps, or you've seen bits and pieces of it, so I'm going to give you kind of one of my interpretations of it, because it can mean a whole different things. It's like a movement, a philosophy, and everything else. I'm going to focus on the practical implementation bits, and I'm going to show you just how to completely rip apart how you're doing security today and make it a zillion times better. Or totally fuck everything up, one of the two, and maybe in the middle somewhere. So what is DevOps? And really it's kind of a new way, if we think about how cloud fundamentally disrupts your architectures and how you build things, DevOps is all about the process of getting those things and building those things. So it relies heavily on virtualization and cloud. It doesn't have to, but for most of you, or for most places it does. It comes from a lot of management theory and lean manufacturing, and kind of taking the lessons of a manufacturing pipeline and being able to convert that into a more efficient way of building software and running your own operations. And I kind of like to break DevOps into 2 parts of it, but I'm going to focus on one core piece of it now, which is how you actually go ahead and write software. And if we think about software development, if you've got a background in developing software, typically you write your code, you commit it someplace, it'll eventually go into testing, and then it'll eventually go ahead and get deployed. And particularly in large environments where a lot of this stuff comes from, what we find is that it's a very, very messy process. And if any of you have ever worked anywhere with normal development processes, this is like, oh yeah, I lived that nightmare. Because we have different teams. We have dev and QA testing, and then we have operations. And each of those teams kind of functions at a different part of the phase, and they all function in different environments. And if you want a long version of this, go read Gene Kim's book, The Phoenix Project, which really describes this very well. And so developers work in dev and their own little tests. Then when you finish code, who's been a developer? What do? You kick it over, code complete, kick it over the fence, and what do you provide? Your binaries and deployment scripts. How do you actually make that code run? How often does that work when you kick it over the fence? Maybe I should ask the ops guys, not the developers, this part of the question. It doesn't, really. Almost always it does not work in a different environment. And in large part because ops is managing all this stuff, dev is managing their own systems. None of this stuff looks the same. And you're going to have all sorts of different testing and staging servers. And one of the main reasons that it doesn't look the same is that over time, in production, things change. We're patching and updating software. People are going in and making database changes, fixing little fields or doing whatever. And those configurations, do they ever get backed out? Does somebody go back to the developer and say, hey, this is what it looks like now? Unless you're using these kinds of processes I'm about to describe. No, they never do. So what happens is that over time, where even if everybody starts with a nice clean slate with all the exact same stuff, that just diverges and diverges over time as production no longer looks like the development environment or like the testing environments. And none of those changes get backed out. And that means that when we go to do updates, it's a much more painful process, and we take a lot longer to push those updates out the door. So my wife used to work at in a hospital system, and they used clinical apps that were highly customized. So it was off the shelf, but all sorts of customizations in there. They could not do dot releases, typically. They would only be able to upgrade about once a year or so, because all of those customizations look nothing like what the developers at these companies that were producing the software looked like. And then even in their own environment, their testing and production environments diverged wildly. I mean, yeah, it was all virtualized for the most part by the time she got there, but nothing looked the same. There have been so many changes in the production databases and systems. It didn't look like their testing environment, and that looked absolutely nothing like what what the actual developers who were writing the code and writing the customizations looked like. And it didn't matter if they were using Agile or Waterfall or whatever other development methodology. In my longer version of this, I kind of go into those more, because what happened is because that timeline took so long, by the time they actually put something in production, it wasn't what the hospital wanted or needed anymore half the time. The physicians would like run off to a conference, it was clinical assistants, be like, hey, look, we found all this wonderful stuff. We want it to look like that. They go, great, we'll get there in 2 years. Well, why can't you just download the newest version? Well, we can't do that for all of these reasons I talked about. So very slow, very error prone. And the other part about it is, it sucks for security. Why? What's one of the biggest problems we have for both security and ops? Change management. Somebody going into production systems and making changes. That whole pipeline of everything that we've got interweaved into itself, how often do we fully know that the configuration is the way it's supposed to be? In a lot of places, we don't. So we do lots of scanning. We use a lot of the tools and things that other people have been talking about here. And all sorts of assessments. We're constantly having to run vulnerability assessments and do agent-based things and look at logs, all of that, because we don't know what's going on. It's constantly changing, and even if you have a change management process, not necessarily the ways that you want things to go, and then the change management takes long and makes it even harder to fix things. So that's the problem. DevOps tries to save all of this by focusing on a deployment pipeline, where we actually use automated processes to write our code and push it into production. Now, I mentioned before, this talk's split into two pieces. This first bit is about producing secure applications and where security can integrate and into DevOps and use some of those techniques. The second half is directly around security operations and using automation techniques, which is a whole other part of DevOps I didn't just describe. So I'm describing the core of the software development piece, but hang with me before the end, we'll actually get into security operations, automation, and those kinds of things separate. So anyway, what is the deployment pipeline? If you haven't used one of these, I like to think about it as 3 buckets. And this is kind of like just one pipeline I've used that I diagrammed out at some point. One is your source code, and all of this is just text files. We keep everything in a version control repository. I have my source code, which is the application. I have CloudFormation or Terraform templates, which, if you don't know, describes your infrastructure. So you can define your entire cloud infrastructure. You can actually even do this with Vagrant and stuff on-prem for virtualization in text files. And you say, run this text file, and it builds your infrastructure out. Now remember, some of what I'm talking about is idealized. If you've used some of this stuff for real, there's rough spots, but it does fundamentally work this way. And then the last is your server configurations. In this case, it's going to be Chef, Puppet, Ansible, whatever you want to use. If you're using containers, Docker file stuff, whatever. So we have our application, our infrastructure, and our actual servers, containers, whatever, if we're using any of those, all defined in text files. Anytime one of those things changes, our continuous integration server will pick up that change and run an automated test suite. It can, depending on how you configure it, in some cases, you can build out entire virtualized test environments in your cloud provider, run all of the testing you want. You can do your Nessus scans, you can do your application code testing within here, you can do everything you want, fully automated testing pipeline. And this is using the same tools, by the way, that developers are using, because this is how they test their code. Okay, maybe they don't rebuild an entire environment every time. Maybe they're just testing parts of the code, but there's a lot of different pieces of testing that get put in here and can get fully automated. And then when that spits out and passes all the tests, it can go maybe into manual acceptance testing, somebody signs off, and then it can get pushed into production. And that could be fully automated, full continuous delivery, continuous deployment, or automated up until this point, and then you have manual pushes to actually, because you might want human gates before you actually go ahead and push that into production. And it's great. But think about how that solves our change problems. Do you ever log into something in production and make a change? No. Fundamentally, for operational reasons, you can't do that. Because the moment somebody commits any changes back here, it will overwrite whatever you do here. It is fucking beautiful. Sorry, Tourette's. It is fucking beautiful. Because now, from a security standpoint, I have all sorts of standardization. I know with almost absolute certainty what something looks like in production. If I need to implement changes, it's idempotent and it will overwrite whatever's going on out there. And if I need testing environments, I can spin up my testing environments. Those are all based on the exact same structure and those always look the same. And it leads into other very cool things that we're going to get into. So where does dev security operations comes in, or DevSecOps? This is about bringing security into DevOps. And it's a couple of things. One, it's producing more secure code. Some people like to call that rugged DevOps, mostly just Josh Corman. And then, he's a friend, I can say things like that. But then the other is to harness the power of DevOps to improve security operations. Because this is our flying car, people, okay? This is the dream. We always talk about, in security, it's like, well, you can have it cheap, you can have it secure, or you can have it reliable, or whatever the three things are that we always talk about. And with SecDevOps, or DevSecOps, or whatever we want to call it, we are more agile, we are more secure, and we are more cost effective. All at the same time. Okay? If you do this right, the downsides are very low. And I love it, because we finally have a concept of trustable security automation that we've never been able to implement before, mostly because vendors lied to us about their ability to trust them to automate things. And we can do this ourselves, and we can do it in multiple places and at multiple layers, and this isn't random analyst bullshit. There are companies out there today doing this for real in production at very large scale. And it's that ability, so I just love this picture, and I put it in like every deck now, and it has very little, it's all about trust. And I mean, it's perfect. You got the ice cream back there. We all know physics, right? You know how that's going to end? Come on. All right. So that's kind of the background and the setup for where I'm heading with everything. And so I'm going to show you a bunch of things. So we're going to show you how to automate security testing as part of your deployment pipeline with a tool made by a James Wickett who lives here in Austin. Is he in Austin or in a suburb? I don't know. He's in Austin, effectively. I'm going to show you how to do rolling updates out in Amazon. I've got a tool that I've been using that I'll go ahead and release because it's not like a big deal. It's just that I don't know why everybody I talk to has to code their own version of it, so I might as well just release my version of it. I'm going to automate incident response in Amazon, and that's something that I've released earlier versions before. I've got a new version of it. I'm doing a bunch of updates with it. I'm going to show you cross-security tool connectivity, so I'll actually automatically insert a WAF behind any web server in an Amazon environment. Obviously, I do a lot of AWS-based stuff. And then I'm going to show you how to build an enterprise-scale platform, and then I've got a cool little extra surprise at the end if I have time. So how do we actually go ahead and automate security testing into this pipeline so I don't have to do a lot of these manual reviews and such? And this is what I'm going to show you right now. So what I have, and I'm going to switch over to environment, I'm using Amazon's code commit repository. It's just an Amazon-hosted Git repository. And then I've got Jenkins. And if I make a code change here, which I'm not going to do because I'm just going to manually trigger the job, Jenkins is going to go ahead, it's going to pull all the code out, and it's going to pull all the configurations out. I'm using Ansible for my server configuration, so to make sure the server's configured properly. And I'm building it all with a tool called Packer. It's all free or open source, everything I'm using here. Now, as part of that process, what it's going to do, it's going to build my instance, or build my image. Then it actually is going to go ahead and deploy that into a test environment in Amazon and run Gauntlet. Gauntlet is that tool by James Wickett, and that's an interface for security testing. In my case, I'm just going to run a very basic Nmap scan because I have to be within the terms and conditions of Amazon for their security testing. So just very, very simple kind of scan. But you can harness in a bunch of tools. And what's really awesome about it, and as you'll see when I run this, is that Ansible uses a length. Basically, you write tests that look like regular Cucumber or unit testing that you would write if you were a developer. So you're writing security tests, and it's using the same frameworks that developers write for their own testing. So if you're doing test-driven development or behavior-driven development, and Gauntlet's one tool, there's Mitten and BDD Security, or two others to kind of integrate in our standard security testing tools into this environment. So what does this look like? And for some of these demos, just because I'm compressing the time that I run things in, we're going to have to go ahead and I'm going to have to flop around screens and everything else. So what I've got going on here is, this is pulling live. So this is a little thing I did. I use this for training classes. I have an auto scale group behind an elastic load balancer in Amazon. This autoscale group color codes based on what instances are running within that autoscale group, and it refreshes about every 5 or 10 seconds. It gives you some of the IDs and some other stuff that we don't need for this particular demo. So that's running all the time in the background there. And as things start changing in production, I'll get into the immutable stuff in a minute, you'll actually start seeing the colors swapping on the boxes here. So I'm going to go in, and my job here, which builds everything, it's called the project website, so this is in Jenkins. I'm going to go ahead and trigger a manual build. And I got to give a second for the UX to refresh here. Or I just hit refresh. I can kind of zoom in as I go along. It's a web browser, so there's limits. And I'm going to go into the console output, which shows me everything that Jenkins is doing. So the nifty, what's going on now is it pulled everything out of Git and into the workspace. It's going ahead, taking a base image from Amazon. It's just their default Amazon Linux instance. It launches that. Then using a script, it connects over SSH. It inserts Ansible, and Packer is handling this piece. And it runs some other command lines and transfers some files into the instance. And so that whole process is get this instance up and running the way I want it to look. Then Packer shuts it down and builds an image, an AMI, based on that instance. And then when it's done building that image, it's going to spit out the image ID. And then I've got other code and scripting and stuff. There's more complexity in here that I'm glossing over that goes ahead and pulls those things, the IDs out, and then sends that to launch an instance in the test environment and run the gauntlet test, and which is the basic Nmap scan at this point. So you can see, this is it installing everything. I designed to keep it really simple right now. It's installing my Sinatra app and everything else that's involved. So I'm going to go back to the slides for a little bit, and then I'm going to jump back over here. Because one of the cool things that we get out of this is the concept of immutable, and truly immutable. Immutable is it doesn't change. Because if you think about it, I said never log into production, ever. That's not for security. That's an operational decision. Because if you log into production, it screws everything up because those changes don't get backed out to everything else. And so the idea is you just replace what's running into production through the automation pipeline instead of actually updating things in the pipeline. And it can be very resilient because places that do this for real, there's no SSH. There's no remote access. Now there's different, I'll call it degrees of immutable. Like the ultimate, you can never touch anything inside of it. And others where we might have some management tools, or maybe we do some code pushes or whatever. So there's flavors of it. But in that ultimate flavor, that thing never gets changed or touched. And this can apply to containers as well as instances. I'm doing all instance-based stuff, but all this translates to containers as well. And so this is that pipeline that I'm running right now, where you take all of these requirements, you implement those in your Packer config, and again, all that's stored in Git, automation, you pull your new image out, and then you get that master image on the other side. And then you have to change the running instances with that master image. And if you're using autoscale groups and you define things properly behind a load balancer, what can happen is you can do a rolling update of all of those instances on the back end. And there's much more obviously complex ways of doing this, so that ideally you don't even break any sessions. And you're actually able to keep 100% uptime. And I did a demo at RSA last year of this, and it took me 7 minutes to update 40 instances, 40 virtual machines. And it could have done faster, could have done slower. That was just the pacing that I picked. And how often do you update 40 servers in production with zero downtime? Which is effectively what I did through this process. Because what you do is you start manually knocking out. So if I knock out instances in an autoscale group, Amazon will replace them, or whatever cloud provider you're using. Boom. But instead of I change the configuration so it uses the new versions instead of the old versions. And so I take my patched ones and I knock out all my unpatched ones, and it gets replaced with patched ones. And it's really awesome. So I talked very fast. Let's see if I talk too fast, let's see how the demo is running. And what I'm really mostly looking for is my gauntlet stuff, which hasn't run yet. Doesn't look like. Yeah, it's still waiting for the AMI to become ready, and then it's going to go ahead and launch the other pieces. And nothing's gone ahead and update. So the other thing that I've got running inside my, so I have 2 jobs in this demo server. One creates the new images, runs all the security tests. If and only if it passes all of those security tests, I do an automated deployment to the autoscale group. I don't have a manual gate. And that's through one of the tools that I'm going to be releasing, or that I did release last night, which is up in GitHub now. And okay, so now it's running the other piece. So let me just go to GitHub real quick and I can show it to you. This is the problem of doing this on a faster pace because I'm actually running ahead of my demos. There we go. So these are messy. I'm releasing them earlier than I planned because I'm actually refactoring all of them to make them better. But this rolling update one, what it does is it actually has a bunch of criteria you can put in. So I want batch sizes of 5. I want it to roll every 1 minute. And which technique you want to use to pull your instances out of your existing security group. I make it fail a health check because then Amazon will more gracefully pull that out as opposed to just going ahead and overriding. All right, so in 2 minutes, Gauntlet will run. I have to give it a little bit of a sleep command because before we run the security test, I need to make sure that instance is fully up and running and everything is going there. Any questions while we're waiting for this part of the demo to run? Yeah.
Can you repeat how you get ELB?
So an ELB just knows. So I'm using native Amazon techniques. What you do is there's 2 parts of an autoscale group. There's the autoscale group and there's the launch configuration. And I point to a new launch configuration which uses a new AMI. Then I manually degrade the health of instances in batches in the autoscale group, and Amazon will replace it. Amazon, if you change, unless you're running in a certain mode with CloudFormation, it won't automatically do rolling updates. At some point, they probably will, and you won't need my code anymore, or anybody else's code anymore. But right now, the only way to do rolling updates is if you do a fully CloudFormation-enabled one. So that's where I've gone ahead and filled in the gap on that process. So while that's running, I'm going to go back to the slides because I was given my 5-minute warning, and I'm not going to hit my 5-minute warning, but I'll get close to it. And so this is kind of the architecture where we have the load balancer, the autoscale group here. You can ignore all this stuff, and then Jenkins is just gracefully degrading these. So it'll kill this off, it'll get replaced, and the load balancer will just shift things around because that's how load balancers work. Now the other thing is we can do a lot with security automation now. So I showed you how to add more security to the deployment process. What cool things can we do to actually be better at security? And this is a set of tools I used to call Security Squirrel. Netflix has their simian army. I have my rodent army, and because it's not nearly as evolved as the simians out there. And if you think about an incident response process, be it cloud, physical, whatever else, what do you do? Well, you've got to, after you detect the compromise, I haven't automated that part. There's a lot of other talks about that part. You have to pull server information and quarantine things, and you've got to image your servers and connect it to a forensic analysis server and do a bunch of analysis and review. And how often does it take just to get set up for the review part, if it's a physical system? Hours, days sometimes to go through all of this? Well, I went ahead and wrote some automation code for that. Okay, and here's the Gauntlet test that actually ran. So it's a simple Nmap attack, and I pass, and if I failed, it would highlight it in red that I failed. And it uses that adapter. And the rules that I have set here is make sure port 22 is closed. There's no SSH enabled on this. And make sure port 4567 is open, because that's the actual port that my little mini app runs on. And I'll keep switching back to this every now and then because you'll start seeing the rolling update now is kicked in. And it's going to degrade the health of these and then replace them with patched instances. So let me go to the incident response demo. All right. I had it set up and then my session crashed, so hold on. And then I need to get, there it's starting to swap out. Now in this case, I'm just doing one at a time. So as I watch, it'll keep all changing color. So that now is on the new AMI, which is the new patched version that I pushed out. It's actually the exact same thing because I didn't do a patch, but. All right, and then let me go back to my EC2 console, and I just have to get my demo server IP address, or instance ID. So what this is going to do is automate a bunch of the IR process. I actually did this at Black Hat like 3 or 4 years ago for the first time. Okay. Oops. Oh yeah, it's IR-functional. Okay, run the workflow, enter the instance ID. So you saw it's a real live running instance, and then it's done. It just ran the whole IR process. So what did it do here? So it did a bunch of different things. The first is I pull all the metadata, which gives me tons of information that I'm going to use for analysis in a moment. Then it quarantines it by moving it into a quarantine security group, so that instance is now locked off on the network. Then it tags it. If you set it with a tag for IR, for incident response, if you set things up in Amazon in my environment, that means only a security admin or a super admin can now do anything in Amazon with that instance. It's blocked off from everybody else using a conditional IAM policy. It identifies all of the attached storage. It was just one volume in this case. It snapshots that storage, launches a forensic analysis server in the background, and then connects the snapshots to it. Or snapshot. Then it just runs some analysis stuff. So this is all just based on knowing Amazon and connecting via the APIs and everything else. So can I run like 4 minutes? Okay. And that is it an auto-scaling group? Nope. So stopping it's going to break things. Are other instances in the same security group accessible from this one? No. And then I rip apart the network stack and look at a bunch of the services. So it could be a web server. It's got SSH running. It tells you what ports it's on. It tells you if it's internet or not internet available. What image was it based off of? Because if it's a vulnerability, now I can go look for any other instances based off that image. And hey, I know there's 2 other instances in my environment that are based off that exact same image that I may now want to go look for that same vulnerability. And then I've got a bunch of JSON that I send out if you want to use this for automation. So that's the incident response automation piece. Oh, looks like my build might have failed. Nope. Okay. I just had a bad refresh. It happens. So that thing's still updating. Let's move on to the next one. And that's available also up on GitHub. So, that's, okay, what? I'm at 3 or 4 demos. So there's other things like I can fully automate inserting a web application firewall. Now in this case, we use Encapsula for our Cloud WAF. So I'm connecting to Encapsula. We use Route 53 within Amazon for the DNS management. And I'm going to be connecting to Route 53. This one I do with video just because the setup is a pain in the butt on it in between sessions because I have to reconfigure DNS and everything else. And so I'm going to run that one as a video, but the code does still work. And what it's going to do is it's going to search Amazon for anything that's internet facing. That's a web server. Could be either a load balancer or an instance. Then it goes ahead and it checks to see if I manage the domain name through Route 53. So that's that list you see there. And then it also checks with Encapsula to see if it has the cloud-based WAF in front of it. If it doesn't have the WAF in front of it, and if I manage the DNS with it, it goes ahead and it provisions, tells Encapsula, put the cloud WAF in front of this. When you do that with Encapsula, they send DNS changes back down. Then I connect with Route 53. I make those DNS changes. And you saw I just put a WAF in place in less than a minute automatically, cloud WAF. So, and that's just one example of as we can start connecting these different products and services together. Then we can actually go ahead and build entire platforms to do this. And this is an architecture for that. Because I have all of these like little scripts and little things that I can do. I need to wrap all of those together so that I actually can manage those at the enterprise scale. And so some people that I've worked with, we've kind of come up with different models for doing this. If you're doing a lot of Amazon stuff, you can do most of this serverless and use Lambda and maybe containers for longer running jobs. And you can link it into all sorts of Amazon triggers. I don't have time to go through the whole architecture here, but when we release the slides, you'll see, this is kind of a basic one. We're using the queue service, web servers, processing servers, API gateways. You could swap some of the processing pieces out for Lambda if you wanted to. And so that you can actually go ahead and run those arbitrary kind of workflows. For example, this is one that I actually have started building on a command line for deploying. Like, I have a new Amazon account. How can I shovel in all the security controls I want? How can I set up all the monitoring the way I need it to? How can I set up all the identity management I need to? I want to do alerting through Lambda functions and using from CloudWatch. Can I shovel all of that into the account? And yeah, and you can build all of it to do that. And then you can go ahead and put nice graphic user interfaces in front of it. So this is an example of that incident response workflow. But here it's running in a GUI. And again, running in a live environment. This is real. And doing it all, nice and pretty with webhooks, user interface, everything else. So the stuff I'm releasing, you can integrate that pretty easily, but you could use like Jenkins or something as your automation tool for it instead of having to go out and build something crazy like that. Then the very last demo is the one of the really cool things that's come out of the cloud providers recently, sorry, can't stop them. Anybody else have kids who've been watching Trolls a lot? My son's addicted to the Trolls soundtrack. It is horrible. He just wants our iPhones and plays it all the time.
Does he use your Alexa for it? Because that's never changed.
Oh God, it's on Alexa? No. No, but we bought Trolls yesterday because it came out on iTunes. Yeah. So what if I want to actually have my infrastructure heal itself and do it in a fully trustable way that's not going to break things? So in this case, if I change a security group, within Amazon, that's recorded to CloudTrail. And when that's recorded to CloudTrail, which is their logging function, I can push that off to CloudWatch, which is a different logging thing that they have. And LogWatch has this cool thing called rules and events. And so I can actually trigger an event anytime somebody makes a firewall rule change. When that event triggers, I launch a Lambda function, which is, you've probably heard about it, it's code running in a container in Amazon that's just always there, and it's all trigger-based. And that Lambda function can go ahead and reverse that security group, that firewall rule change. Anybody have any idea how long this takes to run? About 10 to 15 seconds. So let's go ahead and see what that looks like. That's the last little demo of the day. So if I go into CloudWatch, first I have to turn it on, because I can't make any security group changes if I actually... this code is also all on GitHub. It actually has been for a while. And then I go into EC2. I'm going to just go into security groups and pick a random security group here. All right, let's do this one. So my inbound rules. What do I have here? I know, port 80, port 80. I'm just going to, it doesn't matter what I add. Let me add SSH from the entire world. You don't want to ever do that. I'll add that, and you'll see that, that's a weird UX failure on Amazon's part. Let me hit the refresh there. So that rule has gone ahead, and that's live right now, and anybody could SSH into that box. And it takes a little bit, but as I keep hitting refresh here, I'm selecting that same security group at a certain, wow, where did that little rule come from? That's interesting. Never seen that before. Yeah. And then let me go ahead and hit refresh again. Of course, there's always a chance it won't work because I configured something wrong in my fast running through things, and I'll give it another second. So I'll keep refreshing this, but the end result of all of this is, this stuff is real. You can do it. It's being done in large organizations today. I've got a bunch of these code samples that are actually out there and available if you want to go ahead and take a look. And at this point, I'll do Q&A until they kick me off or nobody has any questions. I'm just going to keep hitting refresh while you guys ask questions. There it goes. One of those rules is gone. That's a weird thing. I've never seen. I don't know what that is. What? No, let's see. Well, it already reversed the first rule, the one that I actually entered. So that's not a functional rule. That wouldn't allow any access from anywhere. So that's kind of interesting to me. Anyway, you see my stuff worked. Or the thing I did work. Yeah?
Have you looked into whether it's faster to make changes to AMIs versus changing things on a web S3? Like keeping AMIs consistent when they change them S3 on the code is faster?
Well, it depends on where your code is, and it depends on how it runs. Containers are faster. I call it units of deployment. And so, and it depends on how immutable you want to be. So some places will do, like I have one that's immutable except for their code, and they actually do SCP to push code in. But the actual instances underlying it are immutable and changed and updated all the time. Containers, it's in seconds. So if serverless is a totally different thing. So yeah, there's a lot of different ways to go ahead and do that. All right. Thanks everyone for your time.